Hello and welcome to Next Gen App Tech. I am Anand. Today we will be going through the topic of data types in C#. So we know that we have to work upon the data on our program because data is the most important part in our program on which our program processes. So we have mainly in C# two kinds of data type, two kind of data, value types and reference type. So what is value type? Value type, we can say that the value which gets stored directly on the stack memory or on the heap memory. It's a big myth that we think that value type always gets stored on the stack and reference type always gets stored on the heap. This is partially true, as value type gets stored on the directly on the stack or the heap memory, that the value is directly getting stored, not any address of it anywhere in the memory. And not all value types get stored on the stack. For example, array elements, fields of reference types. What is fields of reference type? Fields of reference type is like we have a user defined class, so that is a reference type, and we create an object, so that object is a reference type variable. And in that class, if we have a variable of class variable, when we say not in a method, the variable in a method is a local variable, and the variable in a class on the class level, that is a class variable. So those variables, if that is of a value type, those variables get stored on the heap memory, not on the stack memory. As well as the locals in an iterator block, like suppose if we are using a for loop, so that loop is getting iterated. So if we are creating a variable inside that loop of the body of the loop, and that if that variable is of value type, then that variable gets stored on the heap memory, as well as the closed over locals of a lambda or anonymous method. We'll look into lambda or anonymous method in our later video session. So in those things, if we are having a local variable of value type, then that will be get stored on the heap memory, and reference type will always get stored on the heap memory. And few of the value types also get stored on another memory called registers, which is decided by our just-in-time compiler. Just-in-time compiler compiles our intermediate language into the machine code or the byte code which our operating systems understand. Now, what is reference type? Reference type, or we say objects, these types get stored on the heap memory, and the reference variable are stored on the stack. What is reference variable? Reference variable are those variable which stores the reference or address of the objects or the reference type variable created on the heap memory. So when we say that when we create an object, then we need to have a reference variable that will point to that object. So the reference variable or the reference type variable will store on the stack that will contain an address of the objects created on the heap memory. Now we say that if we assign, okay, now we'll go back onto the demo directly. So here we've seen that we have a class called my class. Inside, suppose I have a variable here called int I equals to 2. Right. Now I'm going to write one statement, my class object 1. With this statement, what is happening? With this statement, I am creating a reference variable or reference type variable of this my class. So it is not containing an object. We have not created an object yet. Object creation happens with the new keyword. I'm just creating a variable which will store the address or which will store the reference of the objects of this class. So it will just store the address of the objects. Now I am writing another statement, new my class. With this statement, I am creating an object of my class. So these two are different statements. With this statement, I am creating a reference variable of my class which will store the object of my class, and with this statement I am creating an object of this my class. But these two are not related. As you can see on the memory side, if we'll look into, so with the first statement, I have created a reference variable named obj1 on the stack memory, and we know that reference variable stores the address of the objects, and the address of the objects can be defined in a 4 byte. That's why it is taking 4 bytes. for on the stack memory 1, 2, 3, 4. Now with the second statement, I have created an object of the my class. So this is the object of my class, and it is taking 4 byte again because we have only one field or member or class variable as integer. As you can see here, we have only one variable of type integer, and integer type takes 4 bytes of memory. So we have 4 bytes occupied on the heap memory. And also we know that in my early video session on the stack and heap, I have already explained that on the stack we have a reference pointer or stack pointer. It is a type of variable which is managed by our operating system. It points to that location which says that after that location memory is free. So at the start, if all the memory is free on the stack, so the stack pointer will point above 8000. And I have taken just the number just for reference. I have taken 8000. It can be any number, or it can be any address. So stack pointer will be pointing this. So after the first statement, when object 1 reference variable obj1 will be created, then it will take 4 bytes on the stack, and now the stack pointer will be pointing on 7997, which says that after this whatever memory is there, it is free for you. So it means that from 7996 CLR can assign the memory to the variables. Okay, now these two statements that we wrote, that this object we created and the obj1, the reference variable we created, these two are not at all related. So if this object we created cannot be accessed ever, because whatever the value we want to access, whatever the methods inside that class, or whatever the field inside that class, if we want to access, then those things can be accessed only by a reference variable which will be pointing to this object. So if this reference variable will point to this object, then only with the help of this reference variable we can access the members inside this class, or inside this object to be precise. So if we have I, variable I which we created here, we cannot ever access. If we try to access, then it is going to throw me an error. First of all, object1 dot, just a second, I have to make this variable public. Now if I will go ahead and access, so it is going to throw me an error. It is a compile time error which is saying that use of unassigned local variable. So on the memory level, what happens, I have just created a reference variable. I have not assigned anything, not assigned even null, or not assigned any reference of any object or the address of any object. So it will have some garbage value which is undefined values. So that's why the compiler is throwing us the error, because we have not assigned it. Now in the next statement, if I go ahead and try to assign it with the null, so I'm saying that explicitly I'm saying that this reference variable is not going to reference any of the object, any object in the memory created on the heap. This reference variable is not going to point any of the object, means this reference variable is not going to store any of the reference or any of the address of the objects created on the heap memory. So now the compile time error is gone, but when we'll go ahead and try to run this program, so it is going to throw me an error, that is a runtime error, which is the system.null reference exception, which is saying that object reference not set to an instance of an object, which means this is the object reference. This object reference is not set to an instance of an object. Instance of an object means object, like instance of a class. So on this reference variable we have not set any reference or any address of any of the objects created. That's why when we try to go ahead and the CLR tries to go ahead and run and access this I variable, so it is going to see that what address it is going to contain, this variable, but the CLR sees that hey, there is no address inside this, it is null. Like if the address can be defined in a hexadecimal, then it says that OX0000. So that's why the CLR is going to throw the runtime exception. For that we need to assign reference or address of any object. So we cannot assign any object. Just a second, I'm going to print this. So now we have to assign this reference variable object reference of an object. So I can assign the reference of a or object of this class only. So I have to write, and one more point, that this object can never be accessed, because this object content can accessed only by a reference variable, and not a single reference variable is pointing to this object. So what happens if I will simply I will not write this statement. I will not write this statement, and I will run my program simply. So after some point of time, garbage collection, how does it work? The garbage collection just sees that all the objects created on the heap, so it will see which object is orphaned, which means that which of the objects are not getting pointed by any of the reference variable. So it will see that, okay, this object no one is pointing, not a single reference variable is going to point this object, so it will remove from the heap. So this object will be removed from the heap. Okay, now I'm going to point. So I have to write a statement. I'll just remove this statement. I have to write like this: new my class. So with this statement, what happens, that the object of this class is getting created, and the reference or address of this class we are assigning into this reference variable. Now this object 1 is pointing to this reference variable is pointing to this object. Now with this we can access the content inside this object with the help of this reference variable. So now if we'll go ahead and write this control.writeLine, so now we'll print the value of I, which is 2. So we'll see that, okay, the value 2 is coming. That's how memory that's how on the memory works. Like, that's how the memory management is all about. Okay, now suppose in this method we have a variable, like at this point I have created a reference variable, I have assigned and reference to this object, and now I have a reference variable int x equals to 5. Now what happens on the memory size, as we know that this is a local variable, and local variable of value type gets stored on the stack. This is a value type as well, but this is a class variable. This is a field of this class, this is a member of this class, this is not a local variable. So this variable will be stored on this heap memory, it will not stored on the stack memory, even though it is a value type. That's what I said in earlier. Okay, now with this statement, what happens, CLR will again assign 4 bytes of memory, as we know that integer takes 4 bytes. So the CLR is going to assign 4 bytes of memory on the stack 797996 and 59493. Up to here it is going to assign for this integer, right? So it is going to assign num. Okay, I'll make this as num. So it is going to assign at this level. Now the CLR, after all this happens and the CLR encounters this closing braces, so it means that it is this, the scope of this variable as well as the scope of this variable is going to die. That is, scope goes out of scope, it goes out of scope. So now the memory which is occupied on the stack has to be removed. So CLR doesn't simply remove, like we know that garbage collectors simply remove the object which is not getting pointed to from any of the reference variable, but it doesn't happen with the stack memory. The value doesn't get removed. What happens, the stack pointer at present, what is happening before, at this up to this point, what is happening, the stack pointer is pointing up to 7993, which says that CLR can assign any new value on at this level, the next available memory. Now what happens if it goes out of scope up to here, when the CLR encounters this brace, so the stack pointer is going to point up to here 7997. first it will remove this num, because we know that stack works on the basis of LIFO, last in first out. So the last in was num, so the stack pointer is going to point here, and after that it is going to remove this reference variable as well. So now after that the stack pointer is going to point again here. So if a later point of time, if a new value type is created, which is a local variable for suppose, then the CLR is going to assign the value onto it, which means that the value is going to get overwritten. The value is not removed by the CLR at the time of dereferencing it or moving the stack pointer here. The value is always overwritten on the stack, and in contrast to that, the value or the object created on the heap is removed by the garbage collector. This is very important. Just try to understand this. Okay, this happens like that. So that is what stack and heap is, and that is what value type and reference types are. And if we assign null to a reference variable, so it means it is not referring to any object, and we cannot assign null to a value type. If we want to assign null to a value type, we have to use nullable type, that we will cover in our later video session. And CLR, Common Language Runtime, implements an algorithm to track which objects are still being referenced by a reference variable and which have been orphaned. I just said now. Periodically, the CLR will destroy orphaned objects and return the memory back to the operating system. This is done by the garbage collector. Okay, now what is CTS type? CTS means Common Type System. So every data type which is internally represented by a class or structure. So for example, if we say that whenever we declare an int, we say like int. So this is int, this is an alias. This is an alias of system.struct. Sorry, it is an alias of system.int32, and this system.int32 is actually a struct. So if we'll go ahead and see the definition, then we can see that this is a struct, represents a 32-bit signed integer. So all the data types, primitive data types, or all the data types that is represented by any alias are actually either class or a structure in .NET. If it is in C#, then we can say that for system.int32 struct we represent as int, small int, and in VB.NET, that is again another language which is targeting the .NET framework. In that, to represent system.int32 we write an alias called integer, I capital. So all of these types are actually the either built-in class or built-in structure. So it helps us in the interoperability of the language. Suppose I am writing a C# language, in that I'm going to use VB.NET. So if VB.NET uses integer and the C# uses int, but ultimately it is the system.int32 which will be understood by the .NET framework. So it helps in the language interoperability or cross-language programming. And it defines rules that languages must follow, which helps ensure that objects written in different languages can interact with each other. Okay, now C# has 15 predefined types, 13 value types, and 2 string and object. We'll see shortly and quickly. So integer type we have sbyte, short, int, long, byte, ushort, uint, ulong. So these are the aliases. Actually these are the CTS type of system.sbyte, system.int16, system.int32, and the difference between is the bit, that the sbyte uses 8-bit and short uses 16-bit, int uses 32-bit signed integer. What does this mean when we say signed integer? When we say signed integer, then it can have a value negative as well as positive. As we know in mathematics, we have studied that in integer can be negative as well as positive. So for signed integer, it can be the negative as well as the positive. As you can see, the range -128 to 127. But for some of the data types are also unsigned integer, that it can always have a value greater than or equal to 0. That is a positive value, is like 0 to 255. We have another data type as floating type point type, and it is having a 32 bit. For float, for double it is 64 bit, and its significant figures is 7. What does this mean when we say significant figure? So when we are assigning a float value equals to 3.756, sorry, 45678, something like this. We write f, we have to suffix this with the f to say that this is a float value, otherwise it will take as decimal by default. Okay, now we say that 7 significant figure, so total number of figure 1 2 3 4 5 6 7, so up to here it is like it is going to print. So any value after this it is not going to print, it is going to round off up to 7 figures from here to here. So if we'll go ahead and try to print this value, so like try float, sorry, float value, and we'll see that's 3.46 second, the second value you can see, sorry, CVS 3.467896, 3.46789, and 67 is rounded off to 7. Why? Because only 7 figure it is allowed, 1 2 3 4 5 6 7. So that's what the significant figure means. For double it is 15 to 16, 15 or 16, and the decimal it is 28 significant figures, and it is having very high precision, so 128 bit is used. It will take a lot of memory. And for boolean type it is either true or false, range is only 2. For character type it is a 16-bit Unicode character it represents, and we can represent them with an escape sequence. This, like when we say \n or \t, so \n is for new line, \t is for tab character. As you can see here in the console.write line, if I'm going to write like my name is, now I'm going to use the escape sequence \, I'm writing n. So n is a character, so it can be used with the escape sequence, and escape sequence is the \, which if compiler or CLR detects or determines or encounters, then it sees that okay, we don't have to print \, we have to, it will understand the next character integer, character value. So it sees that n, then it will start with a new line. So I will say that my name is Anand. If I'm going, we'll go ahead and run this program, then it will, value will be output as a new line after my name is. You can see it encounters, the runtime encounters \n, so it is again going to print out with the next line. If we'll try to write \t, then it will take a space of tab. As you can see, if we'll go ahead and try to see, then it will take a tabular space. And apart from that, we have two predefined reference types. Those are the value types: integer, floating, decimal, boolean, and char. And predefined types, we have two types: object, system.object. This is the root type, this is the parent class of all the types, either of all the classes, of all the structs, or whatever. This is the parent or the base or boss of all the classes or and structs, or all the value types and the reference type. And we have strings, which is of system.string. So this is a Unicode character string, or we can say this is a array of characters or array of system.char. We'll look more into string and a string builder in our later video session. So object type is the ultimate parent type from which all predefined types, user defined types are derived. It can be used in boxing, which we'll see in our later video session. Apart from that, object class has 4 predefined methods which can be overridden by any user defined classes. So if we'll see that, just for sake of showing you, if we write system.object, and if we go ahead and see the definition of this system.object, so you can see that we only 4 types, like toString, virtual is written, for equals virtual, for get hash code virtual, for toString virtual, these are written. So these can be, and for equals is having two uh, overloaded methods, and get hash code and toString. So these methods can be overridden as it is a virtual, so we can override these methods into the derived classes, whatever derived classes we are going to create, our user defined classes that we say. So thanks for watching this video. This is a very important topic, data types. So if you have any problem, please do ask in the comment section below. So if you find any error in this video session, or if you have any questions related to it, please feel free to write in the comment section below. You can also download this PPT or presentation by clicking on the link given in the description below, and you can as well give me the suggestion to improve in the comment section below. Thanks for watching. Have a nice day. Bye.